Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our course, Advanced Power Query and M. In this lecture, we're doing a course overview talking about what you will learn in this course and what you will need to take the course. First, we're going to learn how to build expressions with the let keyword. We're going to do a review because this is an advanced version, so we expect that you have some knowledge of Power Query and M. But we will do a short review at the beginning. We're going to learn how to build nested expressions, build lists, and records. Then we'll build expressions with the each keyword, starting with simple expressions and building to more advanced expressions. We'll learn how to generate a list, how to find an entry in a record, how to select items in a list, how to serialize a column, and find the best match for a value. Then we're going to learn how to build M functions to perform tasks, starting with simple functions and getting more into advanced functions like closures. And we'll learn how to build a function in a record. We'll learn about recursive functions with a Fibonacci example. We'll learn how to remove HTML tags from text and how to build the equivalent of a for each loop in M to loop through items in a collection. And more. And then we're going to learn how to work with tables in M, performing queries like selecting a column, selecting a value at a row, selecting a value at a specific row and column, selecting a row where a condition is met, cross-joining tables. As you see here, we have two tables and we're joining them together on a certain key, joining tables, changing column types, and filling tables with random values. Next, we're going to learn how to pivot a table. So taking, for example, a table of topics and courses and cleaning it up so that way each topic is a header, which makes your data a lot cleaner. Pivoting is a key topic and we have a whole section on it. Then we'll learn how to build expressions with the evaluate keyword. This is similar to building functions, and we're going to learn how to build expressions with evaluate. Then we'll learn finally how to work with matrices in M. Matrices are a fancy way of saying tables, but specifically we're going to learn how to multiply matrices, which is a common task. And that is what we're going to learn in this course. Next up, let's talk about what you'll need to take the course. Excel experience is recommended. Power Query and M experience is recommended as well, because this is an advanced Power Query and M course. We're only going to do short reviews. Most of the projects are assuming you have Power Query and M knowledge. We do have an introductory Power Query and M course that we recommend you take before diving into this one. Programming experience will also help if you have experience with any programming language, because M is a formula language. As well, you'll need a PC computer because Power Query is not available on Excel for Mac at the time. So you'll need a PC or a virtual machine that is running a PC. And you'll need a free trial or paid license of Excel. You can get a free trial of Excel without a credit card. Just go to the link on the screen or search up how to. And that is a course overview of what you'll learn and what you'll need to take this course. Coming up next, we're going to do a review of what are Power Query and M, in case you're jumping into this with no prior Power Query and M experience. Then we'll get started building out our projects. This is an exciting course with lots of projects inside of it, and all of the source files will be included for you for every single lecture. The focus is on building useful and fun projects. So I will see you in our next lecture. Hello everyone, and welcome to our course, Beginners Power Query and M. In this lecture, we are going to introduce what are Power Query and M. Power Query is a free tool that is part of Excel and Power BI as well, so you can use it in both. It's integrated into the system, so you don't need to install it. It's not an add-on. It's part of Excel and Power BI. In this course, we're going to be using Power Query in Excel, but you can easily do the same in Power BI. The point of Power Query is several points, actually, several uses. Number one, to automate manual and repetitive tasks typically associated with importing in data and cleaning the data so that it can be used for analysis. As well, Power Query can be used for analysis itself. You can perform data analysis much more easily with Power Query rather than using a complex Excel formula, because Power Query allows you to implement in the M formula language. Here's an example of Power Query. You can take a table and fill in empty cells. With Power Query, it's easy to import and transform data in ways that it would be hard to in Excel. For example, here, you can also aggregate data, filter it, clean it, manipulate it, transform it. You can take a bunch of data about profits per month, and you can translate that into profits per quarter. Power Query was designed to pull data from a source, transform it, and return a transformed version. And since its initial creation, Power Query has gotten more and more tools and capabilities. Another example here, we can take a list of data about sales of a product, and we can count how many times a product appeared in the table. There are three main uses of Power Query. Number one, to import data from many different sources. Number two, to transform and clean that data. And number three, to load data as a basis for reports. Another example here, you can take data about product sales and you can sort the table from the least sales to most sales, or even alphabetical order. However you want to sort the table. You can do that with Power Query and M. This is just one example of some very simple tasks that you can do in Power Query, but you can build very complex queries as well to do complicated tasks. One myth about Excel is that Excel only works with structured data. That is not true thanks to Power Query. With Power Query, we can import data that's messy and then clean it up. And we can get data from a lot of different sources, like a table in an Excel worksheet, or from a different workbook, from a text file, from folders. You can aggregate files from a folder into one file, from a SharePoint drive, from databases like SQL, from an online service like Microsoft Exchange. From the web, you can perform search queries, you can automate web tasks and web searches, you can make API calls. As well, from a data feed or even your Outlook email, you can import this data with Power Query right into Excel. You can also import huge data sets and then manipulate them to get exactly what you want, and then create your spreadsheet so you can work with large amounts of data. Another Excel myth is that Excel cannot handle large data sets, but thanks to Power Query, that is not true. You can make a pivot table from 50 million records, first of all, but also with Power Query, you can work with large amounts of data. You're not restricted to any number of rows because Power Query has its own system, so you can work with a file that has millions of rows and extract what you want. As well, a purpose of Power Query is to transform and clean data. What makes data clean? We define clean data on the most basic term in that each variable has its own column and each observation is in its own row. You can get reports and data from the web, from different sources. That's very, very messy. And it can be hard to clean this data manually or even with Excel formulas. But with Power Query, we can clean our data much faster and it's much easier. And all you need to do is to learn the basics of Power Query. And of course, the more you learn, the faster you'll be able to clean and the more efficiently you'll be able to clean. The time that you take to learn Power Query and M will be worth it. Here's another simple example of what you can do in Power Query. You can take a bunch of columns and you can combine them into one column. For example, for making an address label. The Power Query editor is a graphical script editor. You don't even have to code to use Power Query, but it's recommended to learn M as part of Power Query. This Power Query editor is part of Excel and Power BI. You're going to get to know it well in this course. Again, you don't need to code in M to use Power Query. You can just point and click and do tasks, but it's highly recommended to learn M because oftentimes you'll want to change a query or build your own custom queries that are quite specific to your project. And for that, it's recommended to use M, and you'll find that you will need M as well. But for performing basic tasks, you don't even need M. You could just use Power Query without any coding. You don't have to learn a lot about Power Query to get a lot of benefit from it. A lot of people don't even know that it exists or that it's an option, and they're missing out on a lot of powerful tools. All of the source files will be available in this course for every single lecture, so you can easily follow along with our projects. And this is a projects-based course. We're going to learn by doing, not just by talking about it. So why use M, the M formula language? To build queries for Power Query in Excel and in Power BI. So M does work for Power Query and Power BI. One example here, you can take a table of product sales and you can calculate how much did each product generate in sales as a percentage of total sales. M is a script language or formula language made by Microsoft specifically for Power Query. And M is short for mashup because M is designed to build queries that mash up data. So what does mash up mean? It means combining and changing data to create personalized, customized data sets. Another example here is taking product sales table and ranking the sales. So which of the different products had the most sales? That would be rank 1. The product that had the least sales would have the last rank. M is similar to F#, which is used for financial and scientific applications. And so is M. And that is an introduction to Power Query and M. Join me coming up in our next lecture. We're going to do a course overview talking about what you will learn and as well what you will need to take the course. Very few things. This is quite a fun beginner course with a lot of small hands-on projects that are the best way for a beginner to learn. I'll see you in the next lecture. Hello everyone and welcome back to our course. In this lecture, we are going to learn how to build nested let expressions. Here I am in a new workbook in Excel. I'm going to launch the Power Query editor and get started. Here in the Power Query editor, I'm going to create a new query. This will be a blank query, and I will rename this to nested expression. Then I'm going to launch the advanced editor where I can write some M code. Here for our source, let's replace the source variable with a new expression. We can call this our step 1. And inside of step 1, we can actually use a let keyword to create a new expression and use tabs to indent so that your code stays clean. Then here we can specify some task that we want to perform. We could create variables such as a cost of a product, and then we could have number of sales of a product. Then we can return an expression value, such as taking the cost and multiplying it by number of sales, and just remove that extraneous comma there. So here we have a nested expression inside of an expression, and we can return step 1 and we get the result. So here our result is 1999 times 100, and notice that there will be some rounding. So it's not perfectly 19,999. It's instead just really close to 19,999 because of the way that decimal places are handled in M. Now, as well as having this one nested expression, we could continue to nest as much as we want. Or we can collect as well step 2 and create a whole new nested expression again. We can have our product 2 cost be something different, and then have number of sales again be a different value. And then we can return product 2 cost times the number of sales. So I was able to reuse the variable number of sales because it's in a different expression. Then here in my result, I can return step 1 plus step 2. If I press done, I get a new result. I get the result of step 1 plus step 2. Note that, what if I tried to access number of sales outside of its nested expression? So here I'm attempting to access number of sales. If you press done, you get an error that number of sales was not recognized. That's because it's a variable created in a nested expression, so you can't access it outside of that expression. You can only access variables that are either greater than or equal to the current scope. For example, step 2, it could access step 1. You could take in step 2 the results of step 1. If you press done, you get your result. And that's because variables inside of a nested expression can only access either their own variables or their parents, but parents cannot access their children. And that is how we can build nested expressions in Power Query and M. Join me in our next lecture. We're going to continue building expressions with M. Hello everyone, and welcome back to our course. In this lecture, we are going to learn how to build a list with a sequence in Power Query and M. So let's launch the Power Query editor and we'll get started creating our simple query. Here I'm going to launch a new query that will be a blank query type. So you just right-click, New Query, Other Sources, and Blank Query. Then I will rename this to my sequence. Then we're going to launch the advanced editor so we can code in M. And let's get started. Here for our source, we are going to create a list by opening up curly brackets. And inside of the curly brackets, we can pass in values for our list, such as 1, 2, 3. If you press done, you'll see each of the items is separated by a comma in our code, and it represents one list item. Now, what if we wanted to create a bunch of list items at a time? Well, we can use a sequence for that. So we can use 4 up to 20, like this. By using these 2 dots in between the numbers, we're going to create numbers 4 to 20 in the list. And if you press run, you can see now you have 1, 2, 3, and then all the way up to 20 numbers in the list. And you can add more after that. You can add here 21 and press done. That will give you 21 as the last value. You don't have to add these numbers in order. You could have at the end a -2 in the list. If you press done, you'll have -2 at the end there. You can also repeat elements as well in a list. You could have 1 and 2 all over again and press done. Then at the end there you have more of your numbers. That's because each of the values represents the actual value in the list. This row count, that is just counting off the rows in the list, where each entry is a row. But take note that index counting in lists begins at 0. So actually this number 1 has index 0, this number 2 has index 1. And that's the case in many different languages, including the M formula language. And that is how you can build a list quickly by using a sequence. So we used here these 2 dots to quickly create a list. That does it for this lecture. Join me in our next lecture where we'll build another expression with Power Query and M. Hello everyone, and welcome back to our course. In this lecture, we're going to learn how to build an unnamed record in Power Query and M. So here I'm going to launch a new Power Query editor instance in a new Excel workbook. Then I'm going to create a query, which will be a blank query to store our example. I'll rename the example to unnamed record. Then I will launch the advanced editor and we'll get started writing the query. To create a regular record, we know that we have to use square brackets, to create the record. Then we have a property, and each property is going to have some value. If we paste out the value of this record, we can see we have property and value. And we know that we can get a property value by using square brackets after the record name and then referencing the name of the property. And we get the value returned. But what if we wanted to use an unnamed record? Well, we can create unnamed variables anywhere we want, for example, for a record or for a list or any data type. All we have to do is replace our variable name with underscore. Then you can return the underscore, and if you press done, you get the property and the value. So yes, you can call your variables underscore, and that's the convention for leaving it unnamed. Now, what if we wanted to get a specific property inside of this underscore or unnamed record? Well, you could do underscore and then reference the property that you're referring to in square brackets. If you press done, you get the value. But because this is actually unnamed, you don't even need to reference the underscore. You can just reference the property directly. And if you press done, you'll get the value again. So you actually don't even need to reference the underscore when you have an unnamed variable. If you had another record here, such as our record 2 with another property like course that was hello coding, and you could have a second property, sales, and you have a number. Well, now if you press done, you're still only going to get the value of the unnamed record because record 2 is now named. And you have to make sure you're accessing a property that exists in that record. Now we get hello coding as our value at the course property. So here's an example of two different records, one that's unnamed and one that's named. Remember that variables are immutable, so I can't create another variable called underscore. It's not allowed because that variable is already defined. But you could make a string variable or a text variable be unnamed. First, you have to rename your first record. Now we have an underscore representing our text, and we can get the string underscore. If we try to reference it with nothing, we will get a message though that a token literal is expected. So we do have to use an underscore if that's the only thing part of the name of a text, because for the text object, we don't have any property that we can access it at. And that is how we can build out an unnamed record inside of M. We learned that we can use an underscore, and then we can refer to the record by its underscore. Or if we want to use nothing to represent the record, we do have to represent some of its values, like a value at a certain property. And the M compiler will know that we're referring to the unnamed record here. And the record is unnamed because it's just called an underscore. And that's how you can quickly build records without any names, as well as other variables that are unnamed here in M. That does it for this lecture. I'll see you in the next lecture. Hello everyone, and welcome back to our course. In this lecture, we are going to introduce the each keyword with a short example before we jump into more projects later on in this section. Let's create a new blank workbook and launch the Power Query Editor. Here we'll create a new query for our example. We'll right-click in Queries and make a new blank query. Let's call this query each. Then we will launch the advanced editor to get started. Let's look at one example of using the each keyword. I can use here each underscore, and then I can perform some actions such as multiply each value by 10. Then I can grab my result if I press done. Here we have an option to enter in a value such as 3. If I press invoke, my result is 30 because I passed in 3 and then I multiplied it by 10. Using the each keyword here is the equivalent of using a function. So we can call this source equivalent. Let's make a new variable called source equivalent. And here we're going to take a function. So we're defining a function that takes in an argument that's just an underscore, and then in the body of the function, we're going to take the argument and multiply it by 10. So these two are exactly the same. The each keyword is just a shorthand for writing a function that takes in an underscore as its argument. And we can prove that by using this source equivalent now. And if we put in a value like 4, we get the result of 40. Now, what if we wanted to call the each keyword or use the each keyword on a record in order to get a field from a record? Well, let's take a look at how we can do that. I'm going to create a new query for that. Let's right-click New Query, and it will be a blank query. And I'll call this each on record. Then I'm going to open up our advanced editor. Here, for our source, let's use the each keyword. And this time we're going to use underscore followed by some field. And that is the equivalent of, let's create here source equivalent, of creating a function that takes in an underscore as an argument, and then it's going to grab the field of whatever is passed to it. Now here, this field, this is going to be a specific property, such as, for example, a course name. Okay, so this refers to a specific property. And here what we're doing is we're passing in some value, which will be a record, and we want to get the course name from the record. So let's create a sample record. We'll call this our course record. To create a record, we use square brackets. Then we pass in a property like course name. We can call this Excel. We can have another property like course students, and we can have a number. So here we've created a record with two properties. And then we are going to call source or source equivalent, which do the same thing. What they do is they get the course name property of whatever record is passed to them. So here when we call source, let's call source and pass it our course record. Now if we press done, our result will be Excel, because we passed our function source the course record, and then the function got the course name from that. And doing source equivalent is the exact same thing. Source equivalent and source, they do the exact same function, just each is a shorthand for passing a function an underscore as its argument. And as well, we can try this on course students. We just have to replace then course name with course students, and this time we'll get the course students. And again, the source equivalent and the source are exactly the same. They're just different ways of performing the same task. And the task is to go into a record and to select the course students property from that record. So as you can see, the each keyword makes it a lot faster to write your query. The each keyword acts as a shorthand. Now that we've done an introduction to the each keyword, join me coming up in our next lecture. We're going to continue our look at the each keyword with another project. Hello everyone, and welcome back to our course. In this lecture, we're going to learn how to use the each keyword to generate a list. And we'll look at several examples of how to generate a list. Let's create a new blank workbook, and let's launch the Power Query Editor in Excel. Here we're going to create a new query for our example. This will be a blank query, and I'm going to call this list. Then we'll open the advanced editor so we can write M code. Let's start by generating a list. There are several different ways to generate a list. In fact, we don't even need this let and in keyword. We could just immediately generate the list. For example, we can use list.generate. And let's just make sure we have here, there we go, list.generate. We pass in an initial value function, a condition as a function, and an optional transformation function for what we want to do if we want to transform the data. So our initial function can just be here an empty function, and we can return some value like 1. If you press done here, we need our next argument. So you'll get these prompts. We need between 3 and 4 arguments. So this is just our initial function. After that, we need our condition. Let's say we want to generate values while our values are less than 10, or while we have less than 10. So we'll say each underscore less than 10. So here I'm putting to use the each keyword. Then we pass in the next, or how we go to the next value in the list. And we can say we'll take each and we'll add 1. Now we can press done, and look at this. We now have numbers 1 to 9, which here in total gives us 1, 2, 3, 4, 5, 6, 7, 8, 9 different items, because we stopped once our value reached 10. So here we began at 1, we went up to 10, not including 10, and at each item in the list, we added 1. That way, we eventually reached 10. Let's say we did each plus 2 and press done. This time, at every index, we are adding by 2. So we have a lot fewer because we are skipping over a few indices. We start at here 1, then we're going to go up until 10, not including 10. And at each index, we are increasing our index by 2. Now, what if we started our index at 2? If we press done, look at that. Now we start at 2. Then we're going to increment our number by 2, and we'll stop when we reach 10. Now we have 2, 4, 6, 8, because we started at 2. That was the starting function. And we went until we reached 10. And at each index, we increased by 2. So we started at 2, we increased the index by 2, and we kept doing that over and over until we reached 10, at which point we stop. So that is how you can generate a list with the each keyword. So you can quickly put together a list. You can build a longer list, such as going to 100. If you press done, look at that. Now we have a much longer list, and we're increasing our I at 2. Our index at 2. What if we began at -2 and hit done? This time we'll start at -2, and we again keep adding 2 until we reach at the very bottom 100, at which point we stop the list. And we can also perform more complex queries. We don't have to just add 2 here as our next iteration. We could multiply by 10. If we press done, this time we start at -2. And look at this, we actually are going to keep going on and on for a really long time because we started at -2, which means we started at -2, then we multiplied by 10 and we got -20. Then we multiplied by 10, we got -200. So we actually never reach 100. That's why we have so many values in that column. We'll only reach the end when we hit the maximum number of rows allowed. So we have 999 plus items. If we start at 2, however, and press done, this time we have much fewer values because we start at 2. At each index, we're going to multiply by 10 to get the next index or the next value. So we're starting at 2, then we'll multiply by 10 to get 20. Then we'll multiply by 10 to get 200. But because that's greater than 100, we already stop. We don't include that one because it's greater than 100. And that's how you can generate another list with the each keyword. So as you can see, the each keyword is used twice here, and it's quite handy for writing shorthand how to build a list. So you can very quickly generate a list. That does it for this lecture. I'll see you in the next lecture. Hello everyone, and welcome back to our course. In this lecture, we are going to learn how we can find a property in a record with the each keyword. So I've created a new blank workbook and launched the Power Query Editor in Excel. Here I'm going to create a new blank query, and I'll call this Find. Then let's open the Advanced Editor. Here, let's first build out a function to find a property. And we're going to use the each keyword and search for some property by a property name. Then we have to actually create our record. So let's create a course record. To create a record, we use square brackets. And here we can pass in a property such as a course name, like Excel. We can have a course description, the Masterclass for Excel. We can have course duration as well, such as 50 hours. Now we can search for a property inside of this course record just by passing in the course name like that. Then our result can be the find property rather. It can be the find property, and we have to pass into the find property function the name of the record that we're searching through, which in this case will be the course record. If you press done, you'll get your result, which is the name, because Excel is the course name value at that property. And that is how you can use the each keyword to go through a record and find a course name. Now you may be wondering, what if we had multiple course names here? Like we had Excel, then we had Excel 2. Well, you're actually going to get a message that the field named course name is already defined in this scope, so you won't have the chance to put in multiple fields. That does it for this lecture. Join me in our next lecture. We're going to continue learning how to build expressions with the each keyword. Hello everyone, and welcome back to our course. In this lecture, we're going to learn how to use the each keyword to select items from a list based on a condition. Let's create a new blank workbook and launch the Power Query editor in Excel. Here we're going to create a new query, and this is going to be a blank query. We are going to call it select from list. Then let's launch the advanced editor and we'll get started. First, we need to create a list to work with. So let's do just that. I'm going to create a list of records, starting with some values for my records. We could have here sales and have a value for sales. We could have affiliate revenue and put in another value. Then we could have a course name, and we can use a string here like Excel. Next, let's add in another record to the list. Again, we'll have sales. Then we can have, again, affiliate revenue, followed by a course. And let's call this Hello Coding this time. Then let's put in one more record. Again, we'll have sales. We can have, again, affiliate revenue. And again, we'll have the course name, which will be Python for Finance. Okay, so we have 3 records inside of our list. Next, let's create a function to select from the list. And here, I'm going to use list.select. In here, you pass in the list and the selection function. So our list is our source. Our selection function can be where we're searching for, where each of one of our columns, like sales, is greater than the affiliate revenue. In this case, that would return all of the items in the list, but if we had an affiliate revenue that was really large, then it would ignore that record from the list. We can test this out currently with select from list and then pass done, and we get these 2 records returned. And each of these records is where the sales was greater than the affiliate revenue. And notice we used the each keyword. So we went through a source, we went through a list, and we went through each of the records in the list, and we got where the property sales was greater than the property affiliate revenue, and we selected that one if its condition was met. Now as well, we can return here, instead of select from list, we can return a table from a list. This will convert a list into a table by applying a specified splitting function to each item in the list. All right, so here we need our list, which is going to be this select from list. And then we need to convert that to a table. So for that, I'm going to use record.fieldValues as my splitter. Record.fieldValues here. And finally, we need to name our columns, whichever columns we want to have. as our result, and you pass in those columns as a list. So let's pass in our column sales, a column affiliate revenue, and one more column, our course name. These can be any column names we want, but they should make sense for the records that we have. All right, so now we're going to get returned a table. If you press done, you now have this table. So instead of having to click through each of the values that were returned in the list, we got a table result where we have sales, affiliate revenue, and the course name. So we were able to select from a list the records that met a certain condition, and then we were able to take the result, which was just a shortened list, and we were able to convert it into a table by using our record.field values as the splitter function. So we took each of the field values and turned them into a column. And then we also assigned new column names to our table. And that's how we can use the each keyword to select items from a list. That does it for this lecture. I'll see you in the next lecture. Hello everyone, and welcome back to our course. In this lecture, we are going to learn how to serialize the items in a list, which means to combine them into one string. And also we're going to add a keyword before the last one. So we can have a bunch of items like apples, oranges, bananas in a list. And then we're going to turn that into a string that says apples, oranges, and bananas. So we'll learn a lot about working with text. Let's create a new blank workbook and launch the Power Query editor. Then here in Excel, we're going to create a new query. It will be a blank query. And let's call this serialize. Then we're going to launch the advanced editor and get started. So here, before we start our expression, let's take in some arguments. So this query will be a function. We just need one argument, which is going to be our input list that we want to serialize. And we have to force that to a list type. Our result is going to be text, so we can add as text later on because we're going to take a list item and convert it to text. If you press done currently, you'll see you'll be prompted to choose a list. And for this, if we want to choose a list, then in that case, we have to build out some table that we can then use one of the columns as the list. So let's build out another query to store a table. This will be a blank query, and we'll just build a table right here in the Power Query editor. To build a table, you have to open up not curly brackets first, but first the hashtag table keyword. Then you open up curly brackets and you pass in your headers. You could pass in something here like a product, and then you could have a cost. So these are our headers. Then we need a nested list. So here we need double curly brackets, and each item in the list, or each row in the table will be a nested list. So here we can have a product such as Pluvo, and we can have a cost such as 4.99. That's one entry. Then we can have another entry such as escape code and have 1.99 as the cost. So we have two entries in the table, and if you press done, you'll be able to see your table here where we have a product column and a cost column. So now in serialize, if we choose a column, we can go into table and choose one of the columns and press OK. If you press invoke now, currently our function doesn't do anything, but that's what we're working on next. So we are taking in some input list. Next up, let's count how many items are inside of our list. So for that, we're going to make a new variable called count items, and we can use list.count and pass in the input list. Then if we return count items and press done, in our invoked function, we get 2. We next want to make sure the list has text items, right? So we want to make sure all the items are treated as text. For that, we are going to transform our list into text. So any values will be forced into the text type, and they'll be treated as text. So let's here call a new variable convert list to text type, and I'm going to use list.transform, passing in my input list, not my count items, my input list. And for each of the items, we're going to use text.from underscore. So this means we're taking each of the items represented as an underscore, and we're passing it to the text.from function, which takes a value and converts it to text. Okay, we can test this out now by pasting the result. And this time we'll just get our same list currently because we just had text inside of the list. But if we change this up, choose a different column, for example, if we choose our same table but the cost column, these cost values are numbers. But if we invoke this function, the cost, they will be converted to text. Next, we need to add an and in between our 2 items in the list. If we had 3 items in the list, we would add an and in between the last 2 items. So that's going to be our next step. How do we add a keyword like and between the last 2 items in the list? Let's say here we want to add and keyword. To do that, I'm going to check first if my count items is greater than 1, because if there's only 1 item, then I can't add the and keyword. That would make no sense. But if count items is greater than 1, then we can use list.insert range. This will insert values into a list at the given range. So first we need our list, which was convert list to text type. Then we need our index, which will be our count items minus 1, because index counting begins at 1. So if we have 2 items, we want to subtract 1, because 1 will be the last index in a list of 2 items. After that, we then need the values that we want to insert. And these you place as a list, and we're just going to have 1 value, which is and. Now, one thing we have to make sure of is what if count items is not greater than 1? Well, we can use an else keyword, and in that case, we can just return the original list, which was convert list to text type. Okay, so now if we press, or if we enter the add and keyword and hit done, you'll see we actually have a new entry in each of the lists that has the and keyword. All right, now we want to convert the list to actual text. So I need to transform my item, because as well, let's say I had 3 items. So let's go back to our table and let's add some more entries, like 1 more entry, because then we need to add commas to our query. So let's say we had another entry here called Mammoth, and this was $20.99. If you press done here, you'll have an extra column. And notice here we have Pluvo, escape code, and Mammoth. But we need a comma at least between Pluvo and escape code for converting our content into a serialized text item. So let's add in our comma next. For this, let's go back to serialize, and here we'll continue on with our query. First, I'm just going to add spaces here to make it a little easier to read this long query. Okay, and next, let's add in our serialize list variable. We're only going to add commas if our list count is greater than 2. So we'll check here. If count items is greater than 2, then we are going to add a comma between each of the items. If we need a comma, we have to add those in, but just not between the last word and the and. So let's use list.transform to change our list. Here we're going to use list.firstN. This will return the first set of items in a list by specifying how many items to return or a condition. So first we pass in our list, which was the previous variable. Then we pass in our condition, which will be count items minus 1. This is going to be the first set of items we want. So we want the items except for the last one. All right, and here for this transform, we have our items that we want to transform, but then what is the transform function? Well, we're going to take each of them and concatenate to them a comma. All right, so this list.transform, that was just initially we got what we want to transform with the first n function, and then we actually specified the transformation function. Because we have an if statement, we also need an else statement. So if the count items is not greater than 2, then we don't have to add commas, so we can just return the previous variable. Then we can test out our result. If we go to our invoked function, you'll see here we have a comma between each of our items. Okay, and actually we have to make sure we also have the add and. So let's see, we had the add and keyword. Great, we have to make sure that we have that included. We need to transform all these items and make sure we put a comma between them. Otherwise, we'll just return the add and keyword. So we have here serialized list. If the count of items is greater than 2, then we're going to use list.transform on the list of the add and keyword and go up to -1. Okay, but now we have to put back in the and keyword. All right, so here, after I've transformed my list, and in fact here we could use then like this. We can include here tabs. We could also have the else statement on its own line as well, just to make this easier to read. All right, so here we are transforming the list with a comma, but we also are going to concatenate the and. So here I'm going to use and then I'm going to use list.lastn. This is similar to our previous first n, but last n here will return starting from the last or the final value in the list. Here we can optionally specify how many values to return. We want our list first, the add and keyword, and then we want how many we want to return. We'll return 2. So now we're concatenating on our result, and we can press done. And this time, look at that, we have our and put back in. So we had to add in that extra function call in order to append the and keyword back in there. Otherwise, we just had our first n values with commas, but then we ignored the and the last value. And that is how we can add commas and the and keyword. Now let's convert that all to a text. So I'm going to add one more variable here. This is going to be our list as text variable. And for list as text, I am going to use the text.combine function. And here I'm going to pass in my list and my separator, which can be just a space, which means each item in the list will be separated by a space. If I press done, I can go back to my invoked function here. Oh, let's see, we just have to make sure also that we return our list as text. There we go. And press done. Our result is Pluvo, Escape Code, and Mammoth. So we were able to take all the values and we were able to put in a space in between them and to convert them to text. All right, so here we were able to get our serialized list, which had our items in them, and just add a space between each of them and return the result as a text object. If you want to force the result to be a text, you have to here add the as text keywords. That is going to force the result of the function to always be text. And if you try to return some other value, you'll get an error. If you try to return a number or a date, you'll get an error because this function now has to return a text object, which in our case we do. We are returning a text object. And that is how you can serialize a list with the each keyword. So we used each in several times. Let's see, first in order to actually transform each of our list objects to a text type, and as well in order to transform each of our objects and give them a comma at the end. And those were the two uses of each keyword. I'll see you in the next lecture.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle. And it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.